Assalamualaikum and a very good evening to all the panel, internal, external, and my supervisor, Prof. Dr. Shaiful Jahari. My name is Siti Noor Hajar. First and foremost, I would like to thank for to your time giving and for review my dissertation with title MPLS SR MPLS against SRV6 performance evaluation for QOS in modern network. My thesis inclusive of the introduction, literature review, methodology, result and discussion, and conclusion. For introduction, we have background, problem statement, and objective. As a rapid and acceleration of the modernization technology, for example, the most important, the most famous is 5G network slicing, network data center cloud, SD-WAN, NFB, IoT, and technology acceleration, including gaming, is to improve the network performance, such as throughput, latency, delay, and jitter. With the coming of the MPLS, multiple protocol level switches, which is nowadays the best performance that we have that we require is with segment routing in the MPLS, which is is an emerging traffic engineering technique relying on the MPLS. We have two mechanism, SR-MPLS and SR-IPv6. In this paper, we are focusing on the QOS on combination segment routing with IPv6, which namely SRV6. The problem statement: 5G networks need to be supported by transport network which based on IP-based underlying infrastructure. IP-based technology could be MPLS or segment routing. So the problem statement for the MPLS, in the MPLS we need to use LDP and RSVP, which is imposed to latency, throughput, and jitter on the network. And second, does the low cost and routing policy effectively using segment routing traffic engineering in MPLS can foster traffic? Does IPv6 can only use in the environment of SR-MPLS, or IPv6 only can be used with SRV6, and we have to use IPv4 with SR-MPLS? So the objective for this paper, to analyze and do comparison scalability MPLS, SR-MPLS, and SRV6 on top of QoS performance on throughput, delay, and jitter in modern network. To implement the low cost and routing on forced traffic preferable with enable segment routing traffic engineering in MPLS. To investigate the IPv6 can be used only in a segment routing IPv6, or IPv6 can be used in SR-MPLS environment. For literature review, 5G network slicing, as we can see, the network slicing is logical network that connect to a set of endpoint with a collection of shared or dedicated network resources. 5G network need to serve QoS demand without any interference affected this demand. A slicing is set of a characteristic and behavior that differentiate user traffic type from each other in underlying network. The underlying transport network is required to support dedicated resources license. Network operator is responsible to implementing it with MPLS or segment routing. Segment routing. Segment routing is a new scalability for implementation source routing. It enables network appliance to steer packet through a network path by pre-branding a list of segments included with the packet wanted to be sent. The SR architecture was mainly proposed in order to enhance MPLS architecture by using the source routing paradigm. But by using segment routing, there is no need to protocols such as LDP and RSVP. Segment routing extend already deployed IBTP such as OSPF and ISIS. Segment routing operation have three operations related to SID, and segment. These are defined in the SR data plane as push, next, and continue. As we can see in the figure 2, to show how the traffic from the push active to next and continue segment, whether via a long distance or a short distance. SR example in layman term. So imagine you have to trip from Shanghai to Vienna to Paris, but your travel route can be divided to segment, which is Shanghai to Vienna, Vienna to Paris. Okay. Type of segment, we have global segment correspondent to concept of node SID advertised by IGP, and the secondly is local segment correspond to the concept of agencies SID. Both segments are sufficient to create any intra-domain SR path. Okay, for this slide, I want to show what is traditional MPLS. And traditional MPLS forwarding technology that work between layer 2 and layer 3. The major protocol is MPLS control plane is labeled distribution protocol LDP, and resources reservation protocol traffic engineering RSVPTE, which have some issue on the performance, scalability, and complexity. So coming with SR MPLS, it adopted segment routing in MPLS and resolve low complexity, high efficiency, and excellent extensibility, especially on QOS. No more LDP and SRVP required, which is we use IGP or BGP extension for label distribution. For SRV6 provide greater extensible and does not involve MPLS label. It's shown on the below on the below picture, which is SR MPLS. We have MPLS label, but in the SRV6 we have segment routing header in the IPv6 packet to replace traditional MPLS label forwarding functions. Okay, here the related journal that related to my work. We have the TILFA, which is TILFA is a fast reroute when the restoration traffic restoration of the link. And the second, how the 5G and IoT network can be considered in the foundation building a network generation, and also the other success implement available bandwidth in the SDN via SR MPLS. And then the most related to my dissertation is this author from to analyze in fact segment routing MPLS QoS, but this author using the EVNG in Google platform, which is their only test on the MPLS compared with SR MPLS. Also, we have the author that talk about the POC concept of segment routing, and then we have collect research result in Huawei on the SRV6 expert, which is reflect the latest development direction on the SRV6. Okay, for the methodology, in my dissertation, I developed I install one server, which is Cisco UCS M4. I I loan from my TM lab, which is I put in the connection in the VPN cloud. Okay, by the simulator can be accessed remotely from any site via web base. Okay, we have in this station I use software Cisco Modeling Lab 2.4, which is with license only 20 devices can be used. Okay, I have PE, MP's router, MPLS, Cisco, and then CE router, Cisco IOV. Client and server Linux Alpine. Core IP BGP, I use IS routing between CE and PE BGP. And then piece routing, piece connection is MPI BGP. VRS only one VRF each PE. Okay, iPerf I use to generate UDP traffic throughput and delay. IPSLA I generate UDP traffic for jitter. PE to CE is a client customer edge router to provider edge router, which is like CE connect to PE via BGP, and then LD and then PE to PE is via MPI BGP, PE provider, and then router P is router provider that connection between branches to branches. Okay, this is SR MPLS topology. I make 4 topology as MPLS, SR MPLS, SR core topology, which is in the core I enable the IPv6 or IPv6, but client to server and CE can use IPv4. That's why I can say IPv4 can implement in the SRV6 and vice versa. So this is an SR native topology. All the way client and server is IPv6. Okay, result and discussion. For number 1, latency. The below table show the latency for a bit of data travel across the client A to client server A. As a average, SRV6 show the better result compared the SR MPLS and MPLS, which each result 48% and 10%. Why? While SRV6 native higher bit better with 15% compared with SR MPLS. Okay, for number 2 is it latency is crucial in the gaming? Based on the website bandwidth.com place, 20 millisecond or less is actually as an excellent latency, but the rate 20 to 100 milliseconds seem to be acceptable. So here I compare to I get the comparison latency. Some Malaysia internet user have a server which we can test latency to reach the others outsider gaming server. For example, the average latency to FFXIV Japan Meteor is 77.6. By implementation SRV6, we can improve the latency, which can be reduced to 40.4 millisecond compared to MPLS, and 69.8 millisecond compared to SRMPLS. Okay, number 2 is throughput. I did, as you can see, we did comparison MPLS, SRMPLS, SRV6. SR native, I couldn't show the traffic, maybe of the during that time. That time I some error happened because of the my license. Okay, By average, SRV6 show the better result compared with SR-MPLS and MPLS, which is result is 8 and 20%. With regard to RSR MPLS, a folding state is established by IDP, unlike LDP plus IDP. Superflow state maintained by SR only at the ingress node. Thus, there is no need to using signaling protocols such as LDP. Number 3 is jitter. As you can see, SRV6 and SR native is similar output, but it's much better compared to MPLS and SR MPLS. In the context of the network performance, lower jitter is generally considered better than higher jitter. Jitter refers to the variation of the delay of the packet delivery in the network. It measures a difference between actual arrival time of the packets. High jitter can degrade the quality of voice and video calls, introduce noticeable delay, and lead to poor user experience. Number 4, the last but not least, I test the routing policy, low cost and routing policy, which is I choose SRMPLS traffic engineering, which is where we want to show how we force the traffic via traffic engineering. Traffic engineering actually can help us to manage link during congestion. So number 1, I showed the trace route, which is a load balance before forced traffic, use traffic engineering. Number 1, which we highlight which when we turn on the SRTE, we force the traffic to long pass. So as you can see, the traffic go long path. So from PE1 to P1, P2, P3, P4, and P2 instead of the shorter path. Number 2, after we try to shut down one of the PE1 to P1 link, traffic goes through like an arrow color green. Okay, here when we do the ping, repeat ping, very minimal impact during the restoration. So here I would say the traffic engineering is successful running in this simulation. Okay, for conclusion, by implementing the evaluation was to test for QOS parameter, which are throughput, latency, and delay jitter, and low cost routing policy. Which is for the latency, SRV6 performed the best in terms of latency. Throughput also outperformed both SR-MPLS and SR-MPLS. And for jitter, SRV6 both in the core and native scenario demonstrate significant improvement in the jitter compared to SR-MPLS and MPLS. And the low cost and segment routing traffic engineering showed that we managed to force traffic flow force to selected paths using traffic engineering, but not via short path with minimal impact. IPv4 and IPv6 can both use in SR-MPLS environment. In any MPLS environment, the MPLS label stack sit in the front of the packet being carried. SR-MPLS is just a programmatic way to create label stack. I think is the end of my presentation. Again, I would like to thank to all the panel giving me this opportunity and time to reviewing my dissertation. Assalamualaikum warahmatullahi taala.